And now, in order to train our model, we have some raw data, yeah, from some source. And in order to train our model, in general, we have this kind of division where we some set of data we accept as training data set, and it will be used in order to train our model. And then validation data set is necessary in order to check continuously performance of our model during training process. So this validation data set is necessary in order to tune the features of our hyperparameters of the model. Yeah, and we also need to reserve some amount of data in order to use as a testing data set. So this one, in order to evaluate in final stage the performance of our model. So because sometimes there might be case in which during the training it produces, because during training the performance is very good, yeah, regarding to the validation dataset, but performance can be worse compared to validation test dataset during testing case. So that's why we always need to check for testing for performance using testing dataset. So this is general splitting of our data, yeah. So yeah, this is the same thing what I said before. We have training, validation, and the test dataset. So here some example code in which, as I told before, we have scikit-learn library, yeah. So here we importing some iris dataset, and then we also can, as you can see, all the ready to use code in order to split our dataset, yeah, from scikit-learn. And then here, for example, some linear model called logistic regression is also loaded. So here, as you can see, we can easily split our dataset into train, test, validation, and so on. So there is several types of data splitting and the training process of machine learning algorithm. So here, random splitting method, yeah. So here, for example, imagine we have full data set, yeah. We have some features, yeah, and also target labels. And we want to divide into train and the test validation data set, yeah. So we can randomly split data, yeah. So so it's easy to implement. We just take our data set and divide, for example, in proportion as we told before, like 17, 15, and the 15, yeah. So we can divide like 70, 15, 15 for train and train validation test dataset. So, but so it's a straightforward way, yeah. But it has some disadvantages, like, for example, if our dataset is imbalanced, yeah. What it means imbalanced? So, for example, we have some labels, yeah, some classes, like let's say we have a dataset of images of cat and the dog, yeah, and somehow we could find a lot of photo of cat and the less data of dog, yeah. So it means we have imbalanced data. So it means our model after training will recognize very good, for example, cats, but a little bit worse, for example, dogs, because we had less data initially. So that's why if there is a class imbalance, then it might produce some bias, yeah, after training. So that's why we have another method called stratified sampling. So in stratified sampling, we usually ensure that we have the same amount of data for each class, yeah. So how it works? So this data is divided based on target class labels, yeah. So first we group together, yeah, and we group it according to the labels, yeah, before splitting, and then once we ensure that data size is the same, we start to divide, yeah. So we not randomly split, but we first ensure that we have the same dimension for each class. Here another code with example of stratified split, yeah, with shuffle. So all of these things you can learn, study yourself from scikit-learn, yeah, how it works. And so this is another version of random data splitting, yeah, with stratified in order to prevent unbalanced data set splitting. And the second one is splitting with cross-validation. So what is this? So we have, we divide, so initially we have data set, yeah, and we divide it training set and the test set. And this data set split into k folds, yeah, so k groups of this data, yeah, and we reserve this into different memory, and we each time during training we one set, for example, one fold we choose for testing and the others for training, yeah. In first case, for example, we chose first fold for the test set and the others for training, and the second one we choose fold 2 as a test set and the others for training. So we choose like this, yeah, changing each time, choosing different folds for testing set. We like this do some combinations, yeah. So as I told before, we split into k folds, for example, for 5 folds, yeah. And each time, each iteration, one fold is used as a test set, and the other remaining k-1 folds used as a training set. So this process is repeated until we finish all the folds, yeah, to implement as a during our training. Then we evaluate our model, yeah, with some accuracy metrics. Then at the end, we will have some average performance calculation. So here another example where we use cross-validation, yeah, cross-validation splitting. So now let's talk about. So we here finished about data processing step, yeah. We first we talked about what is a why do we need like pre-processing, yeah, like cleaning, standardizing data set, standardizing data, yeah, normalizing data set, and so on, amplifying some values, yeah, in our data. And we talked about feature engineering, yeah, how to create some which kind of important features to select based on problem, yeah, where we need to remove this some redundant features, information from our data set. Or we can maybe, based on other features, create new features that will impact to our performance, to the performance of the model. And then splitting methods, data set into like training set, validation set, and the test set, data set.